We're Group 8, and our project title for our senior design project is Well Designed in Southern Louisiana Through Normal, Geopressured, and Depleted Zones. Our advisor is Clay Kimbrell. My name is Brandon Newton.
I'm Lexi Abady.
Amanda Addison.
And I'm Dustin Clark.
In order to design a well through normal geopressured and depleted zones, we focused our research for our literature review project, our literature review paper, on these zones and their properties. So we'll go into those.
Geopressure is pressure that is higher than the hydrostatic pressure at that depth. A few ways to geopressure zones can be detected is by wire logging and observing an increase in the drilling rate. The causes of geopressure are undercompaction, tectonic compression, an increase in pore fluid volume, and buoyancy effects. Having a mud plan in place for expected geopressured zones is important because you have to weight up the mud so you don't take a kick, but at the same time make sure it doesn't exceed the fracture gradient. Safety is the most important thing, so you have to detect geopressure so you don't have a blowout.
Depleted formations are any interval of a formation where the pressure of that region is less than the main reservoir pressure. With zone analysis, information should be gathered about the formation from the geologist and nearby wells in order to predict all that we can about these low-pressured zones. Pressure and pore data can be used to calculate the differential pressures of these depleted formations. In mud and casing design, different casing points need to be designed along with a mud that contains a wider particle size distribution that is used to plug off these depleted zones. Common problems that can be faced include severe filtrate loss and mud cake buildup that can lead to many complications such as stuck drill pipe, casing, and tools in the hole.
The casing design accounts for a major part of the total well cost, so it's important for us to choose a minimum cost casing program that will also satisfy our well's conditions. The casing design can be divided into two sections, the preliminary design and the detailed design. In the preliminary design, we're going to look at geologic data to come up with the number of strings and the depth of each of those strings. In the detailed design, we will analyze pressure loading of the well and choose specific weights and grades of casing string for the lowest costs.
In order to come up with our casing design for this area, for this well, we've started gathering data from analogous wells in the area to see how other wells have dealt with the different zones, overpressured zones, depleted zones, and to see what depths the casing is set so we know exactly where these zones are and how to deal with them based on how other wells have successfully completed their wells.
We're going to be determining the selection of our rig based upon the shallow water nature of the location. We'll be looking at the most cost-effective option available. I will also be determining our mud plan based upon the geological data given to us by our advisor. I will be evaluating the different pros and cons between water-based mud and oil-based mud in relation to our well.
Bit selection is critical in minimizing costs and optimizing drilling performance. To select the best bit, we will analyze the pros and cons of different types of drill bits and how each one performs in different types of formations. We will then use the data we have on the formations the well will be drilled through to pick a drill bit that will give us the performance and longevity that we need to be as efficient as possible. Based on the open hole size and the casing sizes for each string of casing, we will be able to determine the volume of the casing annulus it will need to be filled with cement. From this, we'll be able to determine the total amount of cement that will be required and how much it will cost to complete the well. A big factor to be taken into account when planning cementing operations is if there are any zones that need to be sealed off during cementing, like a water-bearing zone. We'll need to make sure these zones are sealed off by cement so that there is no negative environmental impact.
In order to determine drilling costs, I will gather information from nearby similar wells and look at the spud date and completion date to get an estimate on how long it will take to drill our well. Once we know how long the drilling operation will take, we will be able to determine an average rig cost per day. After we figure out how much casing and cement we need, we will look at the pricing of different vendors to determine the most economical choices to stay within our budget.
The most important aspect of drilling a well is maintaining safety on the rig. Pre-tour safety meetings will be held at the beginning of each shift in order for the crew to be familiar with what happened on the previous shift and what is to be expected during the upcoming shift. We will also have to maintain OSHA regulations throughout the entire drilling process, such as requiring personal protection equipment to be worn, presence of safety signs and accident tags, fall protection, proper ventilation, means of egress in case of emergency, and noise exposure. Environmental protection should also be kept in mind. If we decide to use an oil-based mud, there are certain precautions and regulations we must follow. Hazardous materials should be properly stored and disposed of. Blowout prevention should be of high concern, and kill sheets must be made in case of a kick. It is very important to follow all safety guidelines to ensure the safety of the crew and the environment.
So we have been in contact with Clay, our advisor, to get data from him for geological data and for guidance of how to go about gathering data on our own. And we're also have been in contact with him for feedback through our literature review and our presentations and all. So our goals are our short-term goals are to get info from Clay on the formation of the pressure, so geological info and geological data from him, and make some maps to be able to determine the geological features that we expect to encounter for this well, and from that we'll be able to create our well design. After our well design is created, we'll do a cost analysis during the well design as well, a cost analysis to figure out the most cost-efficient way to drill this well and complete this well. So based on casing prices, different types of casing, brands of casing, cement, different brands of cement, different types of cement, and so forth. So our time frame, our map analysis is current right now. That's what we're doing. We have planned to have that finished by the end of the semester. So from that, we'll be able to know what our casing design will be, and we'll be able to have our mud plan done from that. And then next semester, we'll start the rest of our well design and cost analysis as far as rig time and everything else. And so we will work on that a whole next semester, January through March, and then we'll be able to present our final plan by the end of April. Our resources that we've been using so far and will continue to use are SONRIS, the Louisiana Department of Natural Resources online database for well data, Society of Petroleum Engineers papers, online papers through One Petro, AAPG papers through their database, and our advisor Clay Kimbrough has also given us some papers and data to use for our project.